Hi, my name is Bahadur Akhmedov. In this lecture, we're going to discuss how we can find the lengths of the curves using the integration. If, for example, you're given this kind of curve as a red one, f of x, and if you would like to find its lengths between a and b, then you need to use this formula. So the lengths is equal to the integration of this complicated formula from a to the b. So we are going to solve 4 problems in order to understand how to do this technically. So the first problem is a little bit difficult. So we are given the curve. We first of all need to sketch this and then find its lengths. So the curve looks like really strange and difficult, but at a first glance, it looks like the equation of the circle, right? If you remember, the equation of the circle was x squared plus y squared is equal to the 1. So it should be a closed curve. So if you don't have any ideas how to sketch this, the first thing which comes to my mind is to sketch this using some online graphic tools, for example, the GeoGebra. So we are going to go to the GeoGebra here. So I have already sketched this. So you just need to type the x in the power of 2 over 3 plus y in the power of 3 over 2, 2 over 3, sorry, is equal to the 1, and it's going to sketch this curve. It's going to be like the closed curve. And now we need to find its length. So let's go back to our editor. Well, so the curve looks like this, and it's totally symmetric. So in all the sides, in all the 4 sides, its length is equal, are equal, right? So it means that we can just find the length of one piece here, for example. Let's denote this as L1. And the total length of the curve is going to be just 4 times L1, right? So basically, the first thing which comes to my mind is so first of all, we need to define this curve, right? What kind of curve is this in terms of the y? In order to do this, we need to find a y from here. So if we find a y from here, it's going to be y in the power of 2 over 3. It's equal to the 1 minus x in the power of 2 over 3, right? So the next step would be to find a y. In order to find a y, we need to take, so y in the power of 2 over 3. We have to make it simply y. So in order to do this, we take it 3 over 2 from here, right? So since we are dealing with the left-hand side, we have to do the same on the right-hand side as well. So 1 minus x in the power of 2 over 3 in the power of 3 over 2. So we will get the equation for the y. It's going to be equal to the 1 minus x in the power of 2 over 3 in the power of 3 over 2. So basically, this is going to be our y. Now we need to know how the x is going to change in order to find the length, right? So I would like to find the length of this curve where x is going to change between 0 and 1, right? So the length of this L1, so the L1 is going to be equal to the integration from 0 to the 1. So square root of 1 plus y prime in the square, and we have to integrate this with respect to the x. So this is how we are going to find the length of this one piece of this curve. So first of all, we need to find the derivative of this function, right? So we are going to use this formula. First, we need to find the y prime. So the y prime is going to be equal to, so since this is the power function, its power is going to come down, sorry. So 3 over 2 times 1 minus x in the power of 2 over 3 in the power of 3 over 2 minus 1 is going to be 1 over 2. So times to the derivative of this part. So the derivative of the 1 is going to be simply 0. So the derivative from the minus x in the power of 2 over 3 is going to be minus 2 over 3 times x in the power of 2 over 3 minus 1. So we are going to simplify these terms. So please note that this 3 over 2 and this, this minus 2 over 3 and this 3 over 2 are going to be canceled. And we'll have here minus 1 or simply minus, times 1 minus x in the power of 2 over 3 in the power of 1 over t, times x in the power of minus 1 over 3. So this is the derivative of the y. We just need to plug this into the formula of the arc length. So the arc length L1 is going to be, I think it's better for us to first of all find the y prime in the square. So let's find the y prime in the square. So if you square each of these terms, what you get is plus 1 instead of minus 1, right? Times 1 minus x in the power of 2 over 3 in the power of simply 1, right? Simply 1 times, so the square of this one is going to be x in the power of minus 1 over 3 in the power of 2, right? So if you don't understand how we get this, we can just put this right here in this way. So what we get here is 1 minus x in the power of 2 over 3 times x in the power of minus 2 over 3. Right? So we just need to multiply the terms and open the brackets. If you open the brackets, what you get here is x in the power of minus 2 over 3, right? Times x in the power of 2 over 3 minus 2 over 3. So if you just multiply them, it's the same as just adding the powers. It's going to be simply 0, right? It's going to be minus x in the power of 0 is going to be equal to the 1. So this is what we get if you open up the brackets. So this is the y prime in the square. So we need to find the L. So this is going to be the integration from 0 to the 1. So the square root of 1 plus, so x in the power of minus 2 over 3 minus 1, right? This is the y prime in the square. So we just need to plug this to here instead of y prime in the square, and take the square root of this and integrate this with respect to the x. So minus 1 and plus 1 are going to be cancelled, and what we are going to have here is x in the power of minus 2 over 3 from the square root. So if you take the square root, it's going to be equal to x in the power of minus 1 over 3, and we have to integrate this. Okay, so you can simply integrate this. So it's going to be x in the power of minus 1 over 3 plus 1 divided to the minus 1 over 3 plus 1. And we have to substitute the from 0 to the 1. Right? Okay, so if you substitute the 1, what you get here is, so please note that minus 1 over 3 plus 1 is going to be plus 2 over 3. If it goes up, it's going to be 3 over 2, right? So if you substitute the 0, obviously, instead of x, you're going to get simply 0. So the length of this part of the curve is equal, it appears, to the 3 over 2. So that is why the overall length is going to be 4 times 3 over 2. It's going to be equal to the 6. Okay, so let's go to the next problem. Problem number 2. We are given this curve. We need to find its length in this interval from 1 to the 5. Again, we are going to use the same for the previous formula. So where the length of the curve is going to be equal to the integration from 1 to the 5, the square root of 1 plus f prime of x in the square, and its integration with respect to the x. So first of all, we are going to find f prime of x. It's going to be equal to the 2 times 3 over 2 times x minus 1 in the power of 1 over 2, right? So you can cancel out these terms, and what you have here is 3 times x minus 1 in the power of 1 over 2, and we have to plug this to here. So the length is going to be equal to the integration from 1 to the 5, square root of 1 plus 9 times x minus 1 in the power of 1 over 2 in the square. It's going to be simply 2, right? Simply 1. So 1 over 2 in the power of t, it's going to be simply equal to the 1. We take the square root from here. If you open the brackets, actually, what you get here is, so the integration from 1 to the 5 of the square root of 9x. So minus 9 plus 1 is going to be minus 8. And we have to integrate this with respect to the x. So if you want, you can just introduce the new variable, for example, the u. So in this case, the u is going to be equal to the 9x minus 8, and the u is going to be equal to the 9 dx, right? So that is why dx is going to be du over 9. And we just plug everything in to the integration, and we are going to obtain the integration of the square root of u times the u over 9. And the other thing which we have to change is the borders of the integration, right? So if the u is equal to this term, what is the value of the u when x is equal to the 1? So we just need to substitute this to here. If you substitute x to be equal to the 1 to here, we're going to get again 1. So what is the value of the u if the x is equal to the 5? I need to substitute this to here. So 5 times 9 is 45, minus 8 is going to be equal to the 37. 37. So now we just need to integrate this. It's going to be 1 over 9 times u in the power of 1 over t plus 1 divided to the 1 over t plus 1. It's 3 over t. So we need to substitute from 1 to the 37. So it's going to be, I can cancel this. Sorry, I can't cancel this. So it's going to be 2 over 27. U in the power of 3 over t. So from 1 to the 37, it's going to be a complicated number, but we can easily calculate this using a calculator. 2 over 27 times 37 in the square from the cubic. Oh, sorry, 37 in the cube from the square root minus 2 over 27 times 1, because 1 in the power of 3 over 2 is going to be still 1. So this is what we have obtained as the length of the curve. So let's go back to the problems. So this is the problem number 3. We need to find the length of this curve. So now the function depends on x, so that is why the formula of finding the length is going to be slightly different, but the concept is going to be the same as before. So we need to integrate now the function with respect to the y from 1 to the 9. So it's going to be a 1 plus f prime of y in the square, right? And we have to integrate this with respect to the y. So the first thing which we need to do is we need to find the derivative of this function. Derivative of this function is going to be, so probably it's better for me to open the brackets first of all. So x is going to be 1 over 3. So the y times the y, it's going to be y in the power of 3 over t minus 3 times y in the power of 1 over t, right? So now we can take its derivative. Derivative of this function is going to be 1 over 3 times, it's going to be 3 over t times y in the power of 1 over t minus, so 3 over t times y in the power of minus 1 over t, right? We can take out this 3 over t from the brackets, and what we obtain is 3 over t times 1 over 3, it's going to be 1 over t, right? So let me write this. So 1 over 3 times 3 over t times y in the power of 1 over t minus y in the power of minus 1 over t. It's going to be equal to, so I can cancel the 3's, and we will have 1 over t. So square root of y minus 1 over square root of y, right? Because minus tells you that this term should go just to the denominator. If you give the common denominator, what you obtain is 1 over t, y minus 1 divided to the square root of y. Good, so this is the derivative of the x. And what we have to do is we need to integrate this, right? Say 1 plus its derivative in the square. So this in the square is going to be y minus 1 in the square divided to the 4y, right? So this is, its square is going to be equal to this term. So we need to take the square root, and we still have to integrate this from 1 to the 9, right? So if you remember, the borders were from 1 to the 9. So from 1 to the 9. So let's open the brackets and try to simplify the things. It's going to be the integration of square root of 1 plus, so let me give the common denominator right immediately. It's going to be 4y plus y squared minus 2y plus 1 divided to the 4y. Integration with respect to the y. Good. So it's going to be equal to, so if you cancel this 4y with the 2y, it's going to be plus 2y, which is going to be y plus 1 in the square, right? It's going to be integration from 1 to the 9 square root of y plus 1 in the square divided to the 4y from the square root dy. So what we can do is we can just simply take the square root from all the terms here. It's going to be equal to the integration of from 1 to the 9 y plus 1 divided to the 2 from the square root of y dy. So we can integrate this by just dividing every term from the numerator to the denominator. In this case, it's going to be integration from 1 to the 9. So 1 over 2 square root of y dy plus 1 over 2 integration from 1 to the 9 1 over square root of 2 of square root of y, sorry, dy. So now we can just take the integration. So the integration of this term is going to be 1 over 2 y in the power of 1 over 2 plus 1 is going to be 3 over 2 divided to the 3 over 2 plus 1 over 2 times y in the power of minus 1 over 2 plus 1 is going to be y in the power of 1 over 2 divided to the 1 over 2. And we have to substitute this from 1 to the 9. So we can cancel up some of the terms. For example, this 2 and this 2, this 2 and this 2 are going to be canceled. And what we are going to have here is, so I'm just going to put the 9 first of all. So if I put the 9, it's going to be 9 in the cube from the square root, right? So actually, say 9 from the square root is equal to the 3. So it's going to be 3 in the cube divided to the 3 plus, so I have to substitute this to here. It's going to be simply 3. So minus, now we need to substitute the 1. If I substitute the 1, it's going to be 1 over 3. So if I substitute the 1 to here, it's going to be minus 1. So what we have here is, so 3 in the cube, it's 27 over 3, it's going to be 9, right? 9 plus 3, it's 12, minus 1 is 11. So 11 minus 1 over 3. So if you give the common denominator, it's going to be 33 minus 1 divided to the 3, or the answer is going to be 32 over 3. So this is the length of this curve. So do you see, so defining the length of the curves is not so easy, right? So the length is going to be equal to the 32 over 3. So let's solve one more problem. We are given this curve. We need to find its length from where x is going to change from 0 to the pi over 4. Again, we are going to use the same formula, the integration from 0 until pi over 4, square root of 1 plus f prime of x in the square dx. And again, so first of all, we are going to find the derivative of this function. It's going to be 1 over cosine of x times the derivative of the cosine, which is minus sine of x, right? So the f prime of x in the square, it's going to be the square of this things, it's going to be equal to the sine in the square times cosine in the square. So we need to just plug this to here, right? So it's going to be the integration from 0 to the pi over 4. So 1 plus sine in the square of x divided to the cosine in the square of x. And its integration with respect to the x. If you give the common denominator on the numerator, you're going to have simply cosine squared plus sine squared, which is 1, right? That's going to be equal to the integration from 0 to the pi over 4. If you take the square root, it's going to be 1 over cosine of x dx. So since cosine squared plus sine squared is equal to the 1. So we know how to integrate the secant. So this is equal to the secant of x, and integration of the secant of x is equal to the ln of secant of x plus tangent of x. So we have to integrate this from 0 to the pi over 4. So if I substitute the pi over 4, what I have here is ln of secant of pi over 4. So secant of pi over 4 is going to be, so I just need to substitute here pi over 4. It's going to be equal to the 2 over square root of 2, right? So since secant is 1 over cosine. Okay, so plus tangent of pi over 4 is going to be equal to the 1. So minus ln of, so I need to substitute the 0 instead of x here and instead of x here. If I substitute the 0 to here, it's going to be 1 over cosine of 0, which is 1, right? So the tangent of 0 is equal to the 0. So ln of 1 is equal to the 0. And the answer is going to be equal to the ln of 2 over square root of 2 plus 1. So this is the length of the curve, and this was our last example to find the lengths of the functions using the integrations.